Question 2.2. The hardware diagram of an 8051 system is shown in figure 2.2. Right here, port 0 from bit 0 to bit 6, 7 bits, are connected to segment A to G of the 7 segment display. A logic 0 will turn on the segment. Switches 1, 2 and 3 are connected to port 2, bits 0, 1 and 2, and a logic 0 happens when the switch is closed. This microcontroller is also interfaced to LCD where you display switch number ? This question mark is at position 11. So this cell number here is 11, 0 in the XY coordinate. Draw a circuit to connect switch 1 to port 2.0 so that it will detect a logic 0 when closed and a logic 1 when open. So when it's closed, we want it to be logic 0. When it's open, we want it to be logic 1. So when closed, we want it to be logic 0. So closed, you'll be connected to ground, you'll be logic 0. When open, we want it to be 5 volt, so we have to connect to 5 volt. We have to connect it to a 10k ohm resistor, because if we don't have this 10k ohm resistor, then when the switch is closed, the supply will be short circuited to the ground. With the 10k ohm resistor, the current will be lesser, and when it's open, this point will still be logic high, 5 volt. Draw a circuit to show how you connect the common anode 7 segment LED to port 0, bit 0 to bit 6, so that the logic 0 at the port pin will turn on the corresponding segment. Okay, so the bit 0 we have to connect to resistor to here. Likewise here also, connect to resistor to here. This resistor value must be about 220 ohm to about 330 ohm, so as to keep the current at a safe level. Okay, so you'll be from segment A, B to segment G. And this point, the common anode point, must be tied to VCC. Complete the table below for port 0 to display the following pattern. To display a 1 pattern, you need your B and C segment to be on, and the A segment must be off, the rest must be off. Port 0.7 is not used, put it to high. So in this case, we should have a value of F9. So the hex value is 0xF9. To light up the display of 2, we should light up segment A, segment B, don't light up segment C, D, E, F, and G should light it up. This one should be a 1. So in this case, this is 0xA4. To light up 3, you must light up segment A, B, C, D, but don't light up E, F, light up G, and this should be 0xB0. To display E, you have to turn on segment A, B and C don't have to turn on, D must be turned on, D, E, F, G. So this should be 0x86. Right, in question D, we are required to write a function display switch number to display the switch number of the switch which is closed on the 7 segment LED, and insert the switch number to replace the question mark on the LCD as shown in figure 2.2. For example, if switch 2 is closed, then the question mark should be replaced by 2. Only one switch should be closed at any one time. If more than one switch is closed, the 7 segment LED and the question mark position on the LCD should display an E. So this should show an E, and this should show an E. For this part, we are going to write a function called display switch number, which will display the switch that's closed on the 7th segment, as well as display the switch number that's closed over this question mark on the LCD. So the first thing to do is to declare unsigned character switch val, and we'll use this to read our port value, port 2. But because we are only interested in the lower 3-bit and we are not interested in the upper 3-bit, which is not used, we will have to mask out with 0x07. 0x07 is actually 00000111. So when we do this, the upper bits will be masked out, leaving only the last 3 bits. So we will have to set our LCD XY, LCD set XY, and position the cursor so that it's somewhere over the question mark, and that position is 11 0. Alright, once we are done with that, we can switch based on our case. Alright, switch based on our switch value. Alright, case. If it's 0x06, 0x06 means that the last switch is closed, the other two switches are not closed. So it'll be 6, right? So if it's 6, you will do this. You send port 0 equals to 0xF9. That will display a 1 on the LED. And then you have to LCD put char, right? You want to put a 1 ASCII code. Right. Then after that, if it's a case, another case possible would be if let's say this switch is closed, the other two switches are not closed, then this will be 0x05. In this case, we will want to display a 2 on the 7th segment display. That would be 0xA4. It will display a 2, and then we have to LCD put char 2. Okay, then the next possible case would be case 0x03. Okay, that happens when this switch is closed and the other two switches are not closed, so that's 3. So in that case, we have to throw to port 0 to light up a 3. That would be 0xB0. And we have to LCD put char ASCII 3. Now if it's not all these cases, then the default would be you throw your port 0 this value of 0x86 to display a E for error, and then you display LCD put char ASCII E for error. So once that's done, right, once that's done, you can close your switch, and then you can close your function.